Hi, guys, and welcome back to another episode of Women in Math and STEM, where our mission is to reach out to as many professionals, aspiring professionals, students, whatever you name it. We try to reach out to them, who essentially support the initiative of bringing more women and young girls into the STEM field. So, with that being said, as always, feel free to open up the description or transcript to better follow along, and I hope you enjoyed this episode. Hello, and thank you so much for coming to the call today and speaking with me. Just to sort of start off, could you walk us through your academic journey or personal journey and sort of how you ended up as a math professor at Williams College?
So I've always been interested in math and science since I was, a little kid. I was fortunate to have a very supporting home environment where my mom and dad encouraged me. Did my undergraduate at Yale, double major math and physics, went to Princeton for my PhD. And then one of the things I loved about both places is I met a lot of people with diverse interests. And so even though I was trained primarily as a mathematician, I was exposed to a lot of different problems in related fields. And since my graduate days, I've been collaborating with colleagues, across the spectrum, from accounting, marketing, computer science, economics, just all over the place. And it's, one of the things I love about being a math professor. A nice thing about being at a small liberal arts college such as Williams is we teach almost everything. And so while there are certain professors who have areas of expertise, I'm far more of an analyst than an algebraist, we can all pretty much teach anything in the undergraduate curriculum. Plus, we have our personal interests. So it's just a wonderful opportunity to explore lots of different things. And one last thing that I want to remark about is that it's wonderful to be able to work with so many different students, both in person at Williams during the year and through our summer programs, as well as online through programs such as the Polymath Opportunity. And through working with my students based on their interests, my interests grow as well. And so just really get to see the whole spectrum.
Speaking of mentoring students, I think you've mentored over 600 students. I was just
Yes.
wondering what the experience was like and how you make math so appealing and interesting to so many kids.
So I've greatly changed how I mentor over the years. A lot of this is inspired by some of the great mentors I've had from when I was a student. Professor Frank Firk from physics at Yale, Peter Sinek at Princeton, Henry Cabañas at Rutgers. A lot of times my advisors had a large number of students, and it was not always easy to have one-on-one time with them. If you needed it, they found a way to make it happen, but they were busy with a lot of other people. And that was actually good for me as a student. It forced me to be independent. And what was nice in many of these cases is they had other students who were doing similar but not identical things. So you had people you could talk to. And so I've really run my programs like that. So this past summer, for example, I had 17 students on campus working with me on research. And you can't meet with everybody for an hour a day. You run out of hours very quickly. And so the students were phenomenal in working with each other and persevering and getting things done. And it gave them a real sense of ownership. So to some extent, I almost think it's easier the more students you mentor, because the more they work with each other and the more they drive what's going on. It's not nearly as much fun. I had a lot more fun in the earlier years when I was involved in the calculations a lot more. Now I'm far more on the administrative side.
I see. I think you also done a lot of like research in terms of like publishing papers as well as publishing books. I was just wondering, out of like everything you've done so far, what's sort of been your favorite topic to explore as well as like sort of class to teach?
So in terms of the pure math research, it would have to be zeros of L functions. This is the Riemann zeta function related stuff. These are related to some of the most central problems in modern number theory. It turns out there's a lot of wonderful techniques you can use to attack them. You see very similar behavior in number theory as you do in nuclear physics, as you do in some real world economic situations. In terms of impact, I actually serve on a regional school committee, and I don't want to get into too many, well, I do want to get into too many details, but that would take a little bit too long. But we were fully regionalizing, two towns. And the question was, how do you share certain revenues from the state when the state won't tell you what their formula is? And it turns out some elementary statistics, just some simple linear regression, allowed us to do an incredible job estimating what the state formula was. And this allowed us to come up with a good formula to fairly allocate the money from the states. So I love, both ends of the spectrum, the pure mathematics, the excitement to challenge. I love the applied mathematics where the work you're doing at the end of the day is not just going on a shelf. It's actually going to be used and you can see it making a difference. The last thing is I love trying to do the same thing in many different spheres of my life at the same time. So I love the fact that I've written papers with my students and with my children. And a lot of times you don't know where a good source of a problem is going to come from. When my kids were 4 and 2, my son asked me after daycare one day, if you're born on the same day as someone, will you die on the same day? And we created a game called the M&M game where everybody starts with an M&M. You go 1, 2, 3, toss. And if you get a head, you eat your M&M. If you get a tail, you wait. And you try to calculate what's the probability you eat your last M&M the same time as someone else. It turns out you can write down the solution, the probability is an infinite sum of products of binomial coefficients. But if you're clever, you can reduce it to a finite calculation by memoryless processes, by recursion, by graph theory. There's so many different ways of looking at it. There's so much good mathematics that arises that, to me, this is one of the exciting things about being a mathematician, seeing your great questions coming from all over the place and leading to interesting mathematics that can be done by people at all levels.
That's so interesting. I never thought about it that way. Like, if two people were born on the same day, like the
Yeah,
probability of them dying on the same day. I was
yes.
just wondering, like, sort of on the same note, when you encounter like difficult problems, like mathematics problems, or just problems in real life, how do you sort of go about like thinking about it and like trying to solve it?
So one of my favorite quotes is if all you have is a hammer, pretty soon every problem looks like a nail. And there's a lot of ways to look at this. One way is if you're really good at something, you try to find a way to convert it to what you're good at. And so if you're really good at integration, can I convert this to an integration problem? If you're really good in combinatorics, can I convert this to a combinatorics problem? And so it's what are your tool sets? The other way to look at this, which I think is the way to have a very productive, successful career, is to realize that people are smart, people are intelligent. If you're going head to head with smart people, it's tough to make a significant original contribution. What you want to do is you want to go to the land of the screwdriver. If they could have solved the problem using a screwdriver, they would have. They're smart people. If you have a different skill set, you might be able to look at the problem from a different perspective and make real progress. So, for example, I've used some number theory and combinatorics in strange ways in marketing papers because I have a different perspective, a different skill set. And so, if I had to give one piece of advice, you're going to get stuck, but the more diverse people you're talking to, the more different perspectives you'll have, and the more likely someone will say, hey, wait, that's similar to something I've seen before. The more things you have on your radar, the more likely you are. In terms of getting stuck, we all get stuck all the time. One of the things I try to do is I try to look at many things at the same time. And if I'm stuck on one thing, I'll shift, I'll look at something else. And then sometimes as I'm working on that new item, it then gives me a new perspective. The other advice that I would give is we are productive in different ways at different times of the day. Know what hours are good for you. If you need to do long technical calculations, 2 a.m. is probably not the best time to do it. For some really challenging math riddles, I actually find early morning or late at night is the best time for me to do them because then I'm not using advanced mathematics. I'm a little bit groggy and I'm going to try to do things a little bit more elementarily and not try to overthink the problem. So really try to figure out when you work best, try to find a good sounding board, and just, the more experiences you have, the more likely you are to recognize that it relates to something else.
Okay, thank you. And sort of on the same note of like advice and stuff like that, do you have any pieces of advice, recommendations, like suggestions, resources, just honestly anything for students who are interested in pursuing mathematics in the future?
But one thing is, feel free to shoot me an email, sjm1@williams.edu. Based on what you're interested in, I'm happy to, try to work with you as to what would be a good next thing to look at. There's a tremendous number of, good journals out there that are geared towards younger audiences. This doesn't mean that the math is necessarily easy, but it means it's written well. And people take a lot of time trying to think, how can I write this in an accessible way that will hopefully convey some of the excitement? There are some wonderful problems, the Conway audioactive decay sequence, for instance, is a very easy thing to state. We can prove results, which is not always the case, and you can see a lot of great mathematics when doing this. The other thing is there's a lot of wonderful videos out there by people who really know how to tell a story and really know how to animate it. And so, try exploring some of those. Try to find people that you can talk to. It's a lot more fun if you can do this with people. Hopefully your school has a math club, or there might be a math circle nearby. And just when you see these things, don't just internalize them, but talk to people around you and say, hey, what did you think of this? What did you think about this idea? And always try to see, can you push this further? This is how research begins. What if I remove this condition? What if I increase the number of dimensions? How can I find a related problem where now that I've seen this, I can push it a little bit further? And it's amazing how often this isn't done when there's a lot of stuff that you can do without too much additional work. And all of a sudden now you're doing research and you're making your own contribution.
Okay, thank you so much for talking with me. It was absolutely phenomenal. Thank you for sharing your
My
experience.
pleasure. Have a great day. And again, if anybody has any questions, always happy to chat, sjm1@williams.edu. Thank you.
Thank you.